Okay, so this is a panel to talk about new data center cooling technologies. Got some subject matter experts up here. Richard Donaldson from 6Connect, and he also sits on the board of Data Center Pulse. Tesh Durvasala from Telx, he's the CMO and CBO. David Pickut from Equinix, he's the CTO, and Ben Stewart, SVP of Facility Engineering at Terremark. So why are we talking about this? Well, it's all about power. If you take the U.S., for example, 2 to 3% of all power is consumed by data centers, computing rooms, engineering spaces, and a large percentage of that power is a direct result of cooling needs. Power usage needs continue to grow, of course, so those who understand the return on investment for reduction of that power usage or the slowing of the rate of growth are going to have better margins. So this is important to all of us. So current technologies, we're not going to discuss much. Most people understand the basics of perimeter cooling or hot aisle, cold aisle, chiller water loops and compressors. If you don't, you're welcome to talk to any of these guys after this presentation, but we're going to skip them for the purpose of talking about new ones. So Richard, could you start by describing what PUE and CDIE are?
I think we've got this on here. Afternoon or morning, everybody here. Just real quick, by show of hands, anybody here of PUE or DCIE before? Oh, I saw one. Okay. For the routing group, I guess this is sort of an odd topic on the cooling infrastructure, but PUE very simply is power utilization efficiency. It's an industry term that's just coming about where we put the ratio of total effective electrical power going into a data center over the IT load. And then there's a competing metric called DCIE that the Department of Energy is pushing. That's data center infrastructure efficiencies. At the end of the day, we're trying to get the ratio down between the IT load against the infrastructure load. EPA just did a study authored out recently where they identified, I think it was about 100 different data center owner-operators, and the PUE on average was about 2.3, 2.4. So as Aaron referenced, the 3% of power that's being consumed in data centers today, that's an estimate. That is up from a statistical analysis that Jonathan Kumi at Stanford did in 2005, where identified at that point 1% of total U.S. power was inside of data centers. So the spike and hockey stick effect has taken place in the last 5 years and continue to exponentially grow. It's a big issue today. So defining the issue is the first order at hand, getting a metric that everyone can agree on, and I think the rest of the panel will probably talk to that. So the PUE and DCIE are the useful metrics that are out there right now.
So there's a bunch of different new technologies that we're using, or that we're starting to use today, that are considered fairly new cooling technologies. And there's also some bleeding edge cooling technologies that we will get into if we have time. Obviously, this is going to press up against lunch. So some of the new technologies. Anybody want to talk about close coupled cooling technology? Ben?
Wow. Haven't sat there this morning and heard some of the topics going on inside. This is completely off topic. So the fact that very few of you have heard of PUE is not surprising at all. What's really driving this, as Aaron and Richard mentioned, is efficiency, and really for 3 reasons. The first one is social responsibility. When we talk social responsibility, we're talking about tree hugging, et cetera, Greenpeace, et cetera, the greening of the industry. That's not what's really pushing it, though. That makes for good marketing, et cetera. What's really pushing it is cost. As we increase our efficiency, the cost of the utility that we use to power our data centers, which is outrageous. For instance, our facility in Miami, our monthly power bill is $660,000. So if we can improve our PUE by 0.1, that's close to $60,000 a month we're saving. And then the third thing, a lot of these legacy data centers are out there have a lot of stranded space. They don't have any more power or cooling to give to that space, so it's stranded there. By increasing your efficiency, you then release capacity, both power and cooling, to serve into that space. So how are we doing it? Well, the data centers are really looking at one thing right now to improve their efficiency, and that's managing their airflow, separating that hot air from that cold air. And there's a lot of things, as Aaron mentioned, going on. There's hot aisle, cold aisle. There's hot aisle containment, cold aisle containment, and then something called close coupled cooling. That's where we take the cooling element and move it very close to the source of the heat. In legacy data centers, you have perimeter coolers, where you draw your hot air out of the data center to the perimeter cooler, make it cold, push it back under the floor again. That's a very long path for that air to follow, and it's not very efficient. Whereas, if you put an in-row cooler right in your cabinet lineup, and you suck that hot air right out of the hot aisle and blow the cold air back into the cold aisle, you're a whole lot more efficient. That's all I got to say about close-coupled cooling.
Thanks, Ben. How about containment? Anybody want to talk about containment? We'll take.
There's been a fair amount of publicity around containment, specifically putting data center servers in ISO shipping containers. And there are numerous vendors that have introduced these products. You've probably read about these in the trade press. There is an advantage to doing this from an energy perspective. It's a fairly simple one, and it is similar to what we were talking about with close coupled cooling. You're taking a contained smaller volume of air where you've got high density servers and network equipment producing heat, and you are attacking that cooling problem right at the source. That means you have to expend less energy to move air within that contained volume, and then you're able to transfer that heat out of that container and to a heat rejection system in the building much more easily and in a more energy efficient manner than you could in a room this size where you've got servers and switches sitting around. So the approach hasn't gotten much traction in the market, but it's an option that's out there, and it's an example of the type of things that if the end users like yourselves were pushing more at the vendors to see more efficient solutions, we'd probably have some better things on the table with respect to close coupled and energy efficient cooling methodologies.
Thanks, Dave. Tesh, how about talking about raising the data center floor temperature?
Right. Everybody here wants to hear about how we're going to make the room hotter, right? The simple fact of the matter is that when you look at especially legacy centers where you struggle with trying to get more power, more cooling into the facility, and you're trying to maintain a 64-degree environment, do you really need to maintain a 64-degree environment? Can you push the floor temperatures up? Can you adjust your crack units? And I think we'll probably talk about new crack unit technology to a point where you are still within your user specs, but you're probably going to save anywhere from 4 to 5% on your OpEx. And the struggle we have is making this commercially available to you guys, because at the end of the day, there's only so much per kilowatt hour you're willing to spend, or so much per breaker damp you're willing to spend. And as power becomes more and more a problem in some of these legacy facilities, you guys are asking us to figure out ways to contain that cost. You can't have a cabinet cost $1,000 and the power to the cabinet cost $2,000.
Understood. Hot servers. Ben, maybe you could talk about free cooling.
Free cooling. Nothing's really free. But we'll talk about free cooling. There's really two kinds of free cooling on the market out there. There's air side and water side. And even within air side, there's two different kinds. They're now calling it air side free cooling or economization and fresh air cooling. Fresh air cooling is where you really take the cold air from the outside, bring it into your data center untreated, and cool your equipment. Now, that causes some problems, particulate matter, humidity, a lot of issues associated with free air cooling. But it's been done and it works. And especially if you've got a data center that's overheating, your chillers are down and everything, what's the first thing you do? Is you blow open the doors and you use fresh air free cooling rather than let the stuff catch fire. Now, real free air side cooling, you filter it, you then heat it up a little bit so you can adjust the humidity and deliver it to the floor. Still pretty efficient. Some problems associated with that is smoke. If you've got a grass fire in the air and your filtration system doesn't take that smoke out, you've got problems with your smoke detection, your VESTA, your fire suppression system, et cetera. You want to watch that. And another thing we're just now learning about airside free cooling, and you never would have thought of this, is the pesticides used with crop dusting. Now you would have thought, nobody's crop dusting near me. Well, they don't have to be all that close, and you don't need that much. But just a little bit of that pesticide, and there's certain ones, get onto those printed circuit boards. They are extremely corrosive. Not quite sure how you filter that out or even how you check to see if you have those problems in your area. So those are airside free cooling. Great way to be more efficient because you're not running your chillers as much or at all if you're bringing in cold air from the outside. Alternatively, water-side free cooling, you're bringing your chill water outside, running it through fan coil units, and using that cold water on the outside, the cold air on the outside, to recool the chilled water, release the heat into the environment, and bring the chilled water back inside to cool your equipment. That can be extremely efficient. We're using that in our Culpeper facility, and we also couple that with chill water storage tanks. So during the winter, we may be completely on our free coolers, our water-side free coolers, and not using our chillers at all. During the summer, obviously, we're up on our chillers. We can't free cool at all. But during the spring and fall, it may be cold enough at night to use those free coolers, those dry coolers. And then during the day, when it comes time to turn on those chillers, we will have stored chill water in our chilled water storage tank and begin dumping that into the system to delay just a little bit longer that we have to start firing up those chillers and start consuming an enormous amount of energy.
Yeah, you're also seeing some, is this on? Hello? Is this on? Okay. There's also some interesting new units that are combining some of these technologies. I saw in a data center a couple of weeks ago where they have free air shafts going up to the roof, and it can switch dynamically between pulling in free air by testing, constantly monitoring the temperature of the air flow at the output, and then close the vents on the fly when it detects the temperature of the outside air is too high, and start the chiller units up. Really brilliant blend. Anybody want to take on improved crack units? What kind of improvements are being made to crack units?
We're just decoration packages. I have a quick question. We talked about, just briefly, about close coupled cooling, and that's where you bring a heat transfer media or a heat transfer device much closer to the load, which would be your switches, routers, etc. Quick show of hands, if we talk about bringing chilled water into the vicinity of your equipment, even to the cabinet level, how many people get nervous about that? All right, a few. One of the things that can be done in this area also is to do a heat transfer, similar methodology with a refrigerant-based system, where you're using a liquid-based refrigerant that flows through pipes and is converted to a gas. It's obviously not the same as water, because it's not going to drip on the floor, conduct electricity if it gets into equipment. Same thing there. Do people have any feelings about that? Is that something that sounds feasible or reasonable? Okay, so that's one that we'll be talking with the vendors about.
It sounds expensive.
Yeah. Well, that's one of the issues around energy efficiency. A lot of the solutions today are capital intense, and the paybacks may not be as short as we would like them to be. So that gets to Aaron's initial comments about social responsibility and how much are each of us willing to pay for having better energy efficiency and the associated environmental benefits. So, okay. Thank you.
The biggest thing you say, Robert, you're talking about being expensive. If you actually want to get higher densities and you want to get past to where a data center is originally built, you're going to have to put in-row coolers in place, and to pay for those, you're going to be charged a cooling premium, because it's taking extra chilled water to deliver that air closer to you and to actually move it, and we're going to jack the price on you. So you can get it, but you're going to pay for it. But yes, the water is going to be closer. But go back to the days in the 60s and 70s. Every data center had water under the floor everywhere, and that's how it was being delivered. And big supercomputers were liquid cooled. So are we going back to that? Is that what's going to happen? A couple of years ago on this panel, we talked about doing spray cool and all these other things. It's never happened. Everybody's just still pushing air around. So maybe eventually we're going to reach our limits, maybe not. But that's what this is all about.
So I think as a user, though, I think what you're struggling with is, if you're going to save any money, are you passing that savings on, or are you going to continue to charge more per breaker dam? And the customer is still saying, well, wait a minute, I've got more cooling, I've got all these things, but I'm not seeing you pass any of that efficiency on. And I think that's where where we're struggling with. So in the state of New York, for example, NIPERG is offering rebates. So if you can figure out a way to actually use ice or used outside air, you can get a rebate. But I can assure you that when a service provider figures out how to get that rebate, he's not giving everyone a service credit on your KW or your breaker damp usage. So we're trying to push. We're using that savings as a way to fund the capital. But I think the customers are sitting there struggling with how many more breaker damps are you guys going to allow me to draw from this stuff?
So speaking of customers, when you're interacting with a prospect, how much knowledge do they have, and how much do cooling technologies impact your sale at this point? Or are they still undereducated enough where they're just asking about power?
It really depends on your on the prospect, but in primarily in financial services, we're seeing a much more sophisticated customer asking about cooling and processing. Clearly, when we come into a group like this, and if you're dealing with your content folks, they get it. They've either suffered the pains of having to move out of a facility. Just ask Patrick about how many times he has a tough conversation in the course of a month with a service provider. So we at Telx, we're finding that there is still a subset of customers that understand that, we understand we have to pay for power, we move on, because that's not really what's driving their app. There is a larger subset of customers that it comes up every single sales call. And you've also got the different models, right? So you've got the REIT model of pay per kW on a metered basis. People are trying to drive that to the cabinet level. Difficult to get it to the cabinet level because we just don't build our centers that way, especially in legacy centers. So it's coming back to that same question. The cabinet price seems to have a very price somewhere between $800 and $1,200 per cabinet equivalent, but you cannot continue to charge $2,000 to $5,000 for your power to get to that cabinet. So we may be moving to this thing faster than we'd like to.
So it sounds like customers don't specifically care how things are cooled, just that it's cool enough to not melt their servers.
Correct.
So, Richard, you sit on the board of Data Center Pulse. Could you tell us a little bit about what Data Center Pulse is and some things that you're learning through this organization?
So, again, start with a question here. Has anybody heard of Data Center Pulse? All right, there's one. How about the Green Grid? I've got two. Uptime Institute? Hey, all right. We're getting there. All right. So there are a handful of organizations that are out there that are trying to bring data center owner-operators together. Data Center Pulse was co-founded by Dean Nelson of Sun Microsystems. He runs all their global infrastructure, and Mark Thiele of VMware. And what the response was, this was started on, it's kind of an interesting experiment, started on LinkedIn last October. We're now up to 1,000 members, spanning 500 companies in 40 countries. And it's an exclusive membership of just owner-operators of data centers. But the whole impetus behind it was to react to not just customers, but a pending regulatory environment that's coming down from the Department of Energy. Because when all of a sudden you go from 1% of total U.S. power consumption to 3%, you start waking up some people at the federal level that want to come in and start mandating some green initiatives and standards. So it's coming from all different directions, and Data Center Pulse wanted to get out ahead of that and start describing the entire information plan as one holistic system, or what we call the stack. So we're talking a lot of piece parts in here. The vendors you're going to start seeing are going to start thinking about cooling properties of the equipment that they deliver, even at the Cisco level, at the now we're kind of calling it Snorkel, Sun, Oracle, out there coming together. All right, it's a new one. I heard that the other day, so that was kind of fun. But even these vendors are competing for the management of the data center space. So as you look at the entire information plant, or what we call the stack, your inputs, electricity, your outputs are bits and bytes, which you guys control. But in the middle of all this is this electrical consumption and woeful inefficiencies that are out there. And cooling is the low-hanging fruit, but there are a lot of other innovations coming along and just managing the underutilization of the computing resources that exist within that environment as well, too. So that's kind of the work at Data Center Pulse.
Sounds pretty cool. So, Dave, many people believe that air is static, and that temperature, you can set it on one temperature, data center stays the same, you don't really have to do anything. But the reality is airflow is actually quite flux, temperatures are quite flux, and we need some technology to monitor this kind of data. So data centers have to think about sensors and how to react to changes in airflow and temperature. Can you tell us a bit about what Equinix is doing to monitor this and what you're doing with the data, if you're making live changes or if it's aggregate data that's useful?
With 42 data centers around the world, in about 10 years of operating experience, we've developed a number of methods that we use to capture operating parameters and then to optimize the operations center from both an efficiency perspective, but also making sure that every piece of customer equipment is operating in an environment that's acceptable to it. So we use a combination of, when we look at a data center initially, we use computational fluid dynamics to model that center, because it is a very, once you get a data center running, let's suppose that all the customer equipment is at a nominal operating state, there's actually very complex airflows going on inside that environment, but they can be modeled, and then they also can be measured with distributed temperature sensors. And with that data, you can make adjustments to the environment, but as customers make changes to their equipment, or as loads change significantly, you will see some variation there. So it's a fairly well-developed methodology that's being used in the industry, but I'm not aware of anyone that's taken it to the extent of dynamic coupling between that data and actually changing the operation of the cooling systems. There are systems that have been proposed out there. Not aware of any successful implementations. Might be some of the other panel members that are aware.
Yeah, we just saw a couple of weeks ago some interesting new power strips that were coming out with some sensors built into the strip, so you could pull individually on every cabinet. The problem, of course, is getting the number of outlets you need on a strip and the density you need in order to get these sensors in there as well. We saw a few vendors that were building some things, but they didn't quite have the density down. I think that as soon as they can get over a few hurdles, we'll start to see more and more of these things, and then we can actually do something with the data as the availability of that kind of granular data on every single cabinet data center becomes available, and of course cost effective.
I will add, we have one customer, Big Financial, who actually monitors the CPU temperature of all of their servers, and their feedback with us has been a telephone call when there's been problems.
That's brilliant.
I'm going to jump in on, and again, this kind of underscores the point. I want to go back to the concept of the stack. This only illustrates the decoupling of all these disparate systems within the data centers, that if not taken as a holistic view, you get these kind of disparate events going on. So as heat rises or heat bubbles move around, and this microclimatology within the data center gets very complex and very overtaxed, it has reaction throughout the entire center on servers, performance, and everything else that's going on. So each of these little components need to kind of come together under one vision. And there are some systems, I know Johnson Controls is out there trying to bring this together, another couple companies that are trying to kind of optimize the instrumentation of the data center at a physical level, but that's a really new kind of cutting edge thing right now.
Yeah, sure. And one of the other issues that I think we tend to see a lot is in places that have both facilities and operations team, IP engineering people and operations staff are not really talking with facilities. And there's still protocol issues where a lot of crack units don't support SNMP, or a lot of facility-based collection objects are not designed to work with existing NMS systems, and operations staff that are IP-centric really don't know a thing about what's happening in the facility and don't know how to react to it. And slowly those things are starting to come together. I don't know how you find this at Terremark, but I know you run facilities, and there's also a big IP team, engineering team.
Right. Well, we're a little bit different in that our real IT base belongs to somebody else. We're a co-location facility. So our IT base belongs to other customers, and for that reason, our facilities and IT folks work pretty close together. We have a pretty sophisticated private network within our facilities that collects all that data and reports it back to our monitors. But really, push comes to shove, the way it used to be done is all your crack did was look at the air coming back to the crack, look at that return air temperature, and then control itself based on that return air temperature, which is incredibly primitive. And in today's power densities, the environments that we're operating in today, you just can't do that anymore. You need to have sensors out in your cold aisles, and you have lots of cold aisles out there, and you've got lots of cooling equipment out there, and you need algorithms that collects all that data, opens a valve, turns up a blower, turns down a blower, and learns that this is what I need to do to maintain a certain temperature in this certain point on the floor and that certain point on the floor. And the industry really isn't quite there yet, but they recognize the need, and it is in fact going in that direction.
All right, so these are some of the newer technologies that we're looking at right now for cooling. And we're going to talk about some of the bleeding edge ones. Now, I got a list, and I don't even know what half of these things are. Can someone tell me what Kyoto cooling is?
Sure. There's a product that's coming out. It's an air-side economization. It's a Scandinavian firm, I think. You can look it up online. Basically, this is a gigantic composite material wheel that takes air as it comes out of the data center that's hot, captures it at the top of the wheel. As the wheel spins, that actually cools, and then it returns cool air back. So it's kind of a composite material that does the cooling for you in a very gigantic, sort of honeycomb-looking spinning object outside of the data center. It's very James Bondish, if you want to look at it. It's kind of cool, literally. So that's that. There are a couple deployments out in Scandinavia that have deployed it. Yeah. So they're just trying it right now. But again, these are all these issues are kind of trying to push the innovation within cooling. And in fact, just to that point, there's another company I just found out that has now attacked air conditioning as its main engineering focus. And this is something that people have taken for granted for the better part of 30 or 40 some odd years. And this company's actually innovated the evaporative process inside of an air conditioner. So, and I'm getting looks from most people here that kind of you might get when you talk routers with other people outside of this room, but it is actually kind of an interesting technology that someone actually would go focus on this. And those are the types of things that are coming out within the data. And this is going to migrate towards the smart grid and smart infrastructure. So a lot of the innovation that's coming here is going to migrate into other industries.
Fantastic. How about absorption cooling? Who wants to talk to that?
All right. Absorption cooling. First of all, the thing you need in order to really use absorption cooling is extremely high temperatures. If you've got a data center or a facility that's using, for example, microturbines to either generate the power or for backup power, those microturbines produce an awfully hot exhaust. That hot exhaust can be used in a process using a lithium bromide solution called absorption cooling to produce cooling. So in a facility where you're using, say, microturbines, which are very expensive, much more expensive than generators, suddenly become much more reasonably expensive if you're not putting chillers on your facility because you're getting your cooling from the hot exhaust from those microturbines. So that's what absorption cooling is.
I'd love to point out that Ben used to be a commander in the Coast Guard. And he got really annoyed with me when I talked about turbines because they used to have them on all the Coast Guard, some of these Coast Guard cutters and things. And we went to do this, and with that cooling, it actually almost became efficient. We were about an inch away from doing this in our Culpeper facility. So these things are real. A clear thing to point out with like the Kyoto cooling system, I'm pretty confident it's being done on a small scale. When you start getting into our big facilities, let's just say it's a minimum 100,000 square feet. You're talking millions of dollars of risk to do a creative cooling system, and the bleeding edge stuff is going to be, baby steps because nobody wants to risk that many millions of dollars and have a center fail. It could cripple a company.
Well, you could just build two and use one as a test case.
I think that's where the dollars that when you talk about regulation coming in, there's going to be economic incentive to start creating some of these things. There's a great center, a large bank, I'll give you the name offline, that EYP just did in New York City where they have decided to use power during the day to chill or freeze the water in their sub-basement. Then they use that chilled water that they froze at night and use it during the day as opposed to consuming power and water during the day, which is a lot more expensive. They end up saving about 20%, and they're getting more than that back because the state has reimbursed them. So it would, it's not a service provider. So, to your point, Josh, it's not us, not one of the guys on this panel, but a large data center customer can do it on their own.
But Tesh, we're actually when we actually built NODA in Miami, right. There was a district cooling plant in place built by Florida Power and Light. Now, Tico Energy actually owns it now, and they have a giant water tank with glycol pipes flowing through that, and they make ice at night and slough it off. So a lot of our cooling comes from that. There's also chiller plants and everything else and big centrifugal chillers to compensate when they don't have enough ice. But the primary system is a glycol ice tank system. Yeah. So it flows through and makes ice. It's fun. They'll open the door and let you play with the ice and everything. It's great.
Wow. So what is A-Share TC 9.9?
That's ash rate.
Oh,
TC 9.9. The Association of Heating and Refrigeration Engineers in the U.S. got involved with data center standards a few years back. And one of the things that they have been promoting is a wider operating temperature and wider range of humidity for the computer room space or data center space. And there are some companies that have taken this to a limit. And if you go out and look at the specs on the stuff that you buy, it can operate over a very wide range of temperatures and humidities. I don't know how many people in here would be comfortable if their stuff was operating in an 80 or an 85 degree Fahrenheit cold aisle or normal ambient temperature, but the equipment is designed to run that long. So ASHRAE is one entity that's involved in trying to get this entire industry to a greater level of energy efficiency. Anybody here feel uncomfortable if their stuff was in 85 degree Fahrenheit? Any engineers out there?
Touching.
Does that affect the mean time between failure?
I think there's a lot of engineers that would argue that, yes, but by the same token, the manufacturers, I know there are some customers who have gone to manufacturers and said, you say this stuff will run continuously at full load at 90 degrees Fahrenheit, will it do it? And the answer is yes, they've tested it that way.
And I think just to add to that too, even though maybe not necessarily on this panel, but some of the forward-leaning companies in the space that own their own infrastructure, so not a retail, but there's competitive advantage in how you design your data centers, and no plugs intended here for these companies, but Google and Yahoo and Microsoft, and actually a gentleman by the name of James Hamilton at Amazon, I plug him because his blog in this area is just fantastic. But these companies are now pushing forth their data to share with everybody on how they've made their economization. So Google on April 1st, it's April Fool's, but they actually came out and kind of demonstrated what they've been building as far as data centers. It was granted 2 or 3 years old, but this was the container vision. Microsoft has a new campus in Chicago now that they are publishing a lot of information about that's outdoors. So it's containers, but outdoors. And then there's even some stuff coming down the pipe here where Google's now filed a patent, and I think they were accepted for it, for the data center on a ship that is powered by tidal power, if you can believe that.
Wow.
So just to the point of warming up that data center, though, that's something you have to design the data center for. If you take a legacy data center and run it at 85 degrees, you've got problems, because what happens when you lose your power is your chillers shut down, and it can take 10, 12, 14 minutes for those chillers to fully restage and return to full capacity. In most of your high power density data centers, you don't have 10, 12, 14 minutes worth of cooling left within that building to survive that. So if you're already starting at 85 degrees, you're going to be in trouble. Whereas if you're starting at 65 degrees, you've got a little more time to recover from something like that. Which isn't to say that you don't run your data center warmer, but you have to engineer it for that.
Question or comment at the microphone?
Joel Yeagley. So, I mean, one of the questions with running your data center hotter is, of course, a higher thermal gradient obviously makes air cooling more efficient. Certainly we have components and systems today that we could engineer to run at outlet temperatures of, like, say, 50 C, but you may not like that when the air coming into your data center from our hot racks is that hot. And certainly spinning disk components don't like that too much either.
Fair enough. Rob?
Rob Seastrom. There was a comment that I wanted to make and an observation and a question. The first comment is that one thing that I didn't hear anyone take into account when you're talking about having your data center temperature go up to 85 degrees, pardon me, is MTBF on your data center technicians. And we have problems recruiting and keeping intelligent people in those positions to begin with, and making the work environment less appealing by making it a place that's warm enough that you come out of the computer room drenched in sweat. Is not really a step in the right direction. So the people who try to monetize that will almost certainly monetize it in their model as a very low number compared to the actual operational impact that it has on our ability to get the job done.
Rob, we're just going to put you in a cooling spacesuit and throw you through the data center and see what happens.
Well, I like the idea of the whole submerged data center and going in, swimming in the cooling fluid with the aqua lung on, but that's just my personal preference.
I want to volunteer. You can see I'm wearing a sweater and long pants because I'm always freezing. So anytime you need me to help you in an 80-degree data center, I'd be glad to help you out.
You can have a future direction doing that, Brandon.
There would definitely be a promotion over where I am now. So
the other question is, the whole lithium bromide is an absorption cooling medium rather than traditional ones such as anhydrous ammonia is kind of a new one on me. I wasn't aware that it was used for that, and I don't think it's necessarily as nasty as NH4 is, although it's certainly the MSDS gives me pause, but MSDS has always given me pause. Cogeneration and being parked next to a plant that's making electricity and offers a cheap source of low pressure steam that's still quite hot is not a new one on anyone who's been in the petrochemical industry. So the question is, are we starting to build data centers next to power plants for reasons other than wanting the power? And I don't mean green power plants either. I mean big old nasty coal burners and nukes where we can actually get steam out of it. Anyone want to?
I can answer that question. As we've looked at cogeneration, one of the difficulties is that the uptime for a cogen plant is 94 to 95%. So when it is down for maintenance, you do need to have an alternative source. So to do something like that, that means you're going to have to get that 6, 10, 12 megawatts of power from another source. Utilities don't want to have that much in reserve. If you could co-locate next to a huge utility that had multiple cogen plants, et cetera, you would have that level of redundancy.
And I don't know how the economics would work of just firing up a boiler to make your own when the utility was down, but maybe not so much.
I can talk to this, Ben, what was the name of the company? I forgot, I blanked out on those turbines. The Capstone Turbine Array, what was the company that we were looking at for the turbines?
Oh, it's actually a division of United Technologies.
United Technologies. So what they were doing was creating 200 turbines in an array, so you could take up to 15% of them offline for maintenance. But still, our clients, that'd just be primary power, maybe using utility as a backup, but the utility doesn't want to deliver dead circuits. So you still have to back that up. So, we're building, a lot of us are building 100 megawatt sites, so that's 52 megawatt generators, backup engines for backup on top of the turbines. It's just so much money. And hey, if you guys want, 4, 6, 800 watts a square foot and you want to pay us for it and you'll sign contracts before we build it, sure. but risking our companies that way, it's just no way.
And just to add to that, the great book, if you haven't read it yet, is called The Big Switch by Nicholas Carr. It kind of talks a lot about what you're talking, which is the nexus of power and information. And I think you're going to see a lot of that starting to be blueprinted in designs coming out here in the industry. And I know some people that are specifically talking about that right now.
Was it Mr. Underwood or front mic or back mic? Front mic.
He was there first. Okay. Thanks. Pete Humman, graduate student, former network and data center engineer. Question that occurred to me while I was listening to this discussion is that early on, you gents talked about the power consumption effectiveness of an entire data center, and a lot of this discussion has been focused on how do we cool the entire data center. I'm curious if there's any more fine-grained efforts being made, both in terms of measuring power consumption, let's say within a row of racks, a single rack, down to the individual device, and then counter to that, or in conjunction with that, then are there any fine-grained efforts in terms of trying to cool just a subsection of the data center?
Probably one of the most promising ways to cool just a subsection is heat exchangers that are right there at the cabinet level, and products that just recently been introduced to the market. Sun just provides just announced a product that's available now today for 30 kilowatts of cooling per cabinet, right there at the cabinet level.
Certainly from an educational standpoint, a lot of the work at Data Center Pulse, we have a thing called the Chill-Off, and it's vendor-sponsored, and we've got DOE as well. Lawrence Berkeley is involved, and that entire purpose is to test these types of things for 30, 50, 100 kW cabinet builds. So things that are coming out now, and I know a couple people are working on some fanless servers, if you can imagine that. Also some chilling plates versus liquid-cooled alternatively within racks. But the whole purpose of that Chill-Off is all public. That's datacenterpulse.org. You can check it out. There's a lot of innovation there.
I think all of us on this panel already offer, probably 3 flavors. There's a low-density cabinet with probably something below 2.5 kW. There's a high-density cabinet of something above around 5 kW. And then let's face it, we all have customers who are using 10, 12 kW, and we figured out a way to make sure it stays cool. So that's the unofficial product that's out there that we're figuring out a way to cool. So it's commercially available right now in terms of different kW for different cabinet footprints.
Great, thank you.
Todd?
Todd Underwood, Google, I guess. But I don't know anything about that data center stuff. I wanted to make a lot of this has been a conversation about the technology and about the systems engineering approach. But one of the things that has struck me for years is that this is fundamentally about a division and a misalignment of interests. There has always been good technology here. When you look at why companies, like the point was made, Google's doing fascinating, really cool stuff. Amazon's, why are they doing that? Because they own the entire thing. They're buying the power, they built the building, they picked the rats, they bought the servers, they bought the network gear, and it is in their interest to fix the whole thing so it works right. Almost everyone up here is stuck in the unenviable position of trying to align your customers' interests and your interests given only the crude tool of pricing and marketing. Right? And so that's what I'm interested in is there any way, when Blade servers came out, nobody thought Blade servers made any sense. And the reason Blade servers made sense was because we were all selling space. And so people are like, oh, well, screw it. I'll optimize the space. I'll just load up on power. And that went on for a little while, and we were all like, oh, no. Okay, now I'm going to start selling power plus space. Or maybe just power. Or, right? We're given these very crude tools to adjust our customers' behavior. And what I'm interested in is, have any of you come up with more sophisticated, more clever, more effective ways of making sure that your interests as the designer and financer and operator of the building has a shared set of interests with your customers? Because right now, it's mostly adversarial, and I think the customers tend to be winning. So, I'll take that question off.
That's a brilliant question. Anybody want to take a stab at it?
Todd, I think that because of the different interests, unfortunately, that's why legislation, is looming, and there are bigger entities that are looking at that. I will tell you that we've seen, in the last few years, I've seen much greater interest from customers to do something and work with us cooperatively. And we have initiatives going with 3 or 4 customers right now where they're willing to bear some pain of reconfiguring their stuff into a more energy-efficient configuration using some of these newer techniques. But it really has to be a cooperative thing where there's a joint interest in doing it. But beyond that, I don't know that there's an answer for it.
Todd, I think a good point would be in a data center where you got, let's say there are 20 tenants in one pod, and you've got some guy with a bunch of CRS-1s blow drying the guy with the servers next to them. What you do is you put up a nice sheet of plexiglass to deflect the hot air up. In multi-tenant environments, you try and space manage as you lay them out, but we're here to sell data center space and provide cross connects, and other peering ports and other services to people. We just kind of, occasionally hack job it together, for lack of a better description, and make it work as best we can to provide services to customers. And fortunately, it seems to work.
Well, I do believe that we have created products, the high-density, low-density cabinet, and then maybe what's going to be a super high-density cabinet, a 15 kW type cabinet, is because of that dislocation between power consumption and cooling capacity and what the customer is willing to pay. Or said differently, what customers want to buy up front so they don't get stuck when they actually need the power, because they never know what they're going to use day one, and day 300 of installation could be entirely different. And I think at some point, people have been stuck in that situation where they want to draw a few more amps and it's not there. And that's really annoying.
And also jumping on that, because you're asking a phenomenal question that I think, from the standpoint of a paradigm shift, we're sort of undergoing that right now. And the analogy I would go to is, climate change in that conversation. And that's inspired a lot of people to go out and trade in SUVs for a Prius. Now, that's more the marketing side of raising awareness, having a conversation, and pointing out to people that, quite frankly, the single largest, in my opinion, greenhouse gas emitter, if you want to go down that road, is the IT industry. Because the metrics we're giving just are the known data centers, and quite frankly, they really don't know half the stuff that's out there in enterprise facilities, at home. I couldn't even find a power slot to put my laptop into today. So there's a lot of power being consumed just in this room alone. So again, it's an awareness issue, and customers, I think, ultimately will begin to ask for these things, and you'll start seeing Energy Star ratings on buildings and data centers that show up. So it'll help kind of drive the customer towards more energy efficient solutions.
Thanks.
Back microphone.
Dan Ellis from Pentola Data. Has there been any successful use of a commonization between what the heat that's pulled out of the data center to heat the rest of the building that may be occupied by offices, especially in the colder climates?
Yeah, I mean, you do see that, but not in Miami. Don't know why. We have a data center I can't necessarily talk about yet, but it's going to be pretty interesting. It's I'll just say it's a good way to de-ice runways. Kind of interesting concept. But, you know, a lot of those things are green Band-Aids. You know, it's great use of waste heat, but and you feel efficient for doing it, but it is a Band-Aid per se to say you're doing that. It's just, you know, a good way to use the hot air, but definitely not in Miami.
Thank you.
Joe Lyman with CHL. Kind of more along that lines, something efficient, something practical to do with that heat, the heat engines or anything of the return on that. That's what I think there might be some kind of usefulness to put some interest there. And you may not always want to be heating your actual rooms with that kind of heat, but heat is actually a form of energy, and you can make use of it if you can do so efficiently.
Unfortunately, it's heat that coming off a typical server or a piece of equipment where there's a 20-degree rise, let's say, through that, and you start it at 70, it's 90-degree air. It's 90, 100, 110-degree Fahrenheit air, and it's in large volumes. It's very hard to efficiently extract that heat and use it for something else. In a multi-campus or multi-purpose campus, you might be able to get some of that, but it's just very difficult when it's in air. Now, if you are recovering that heat through a heat transfer media, water, refrigerant, you have a better chance of being able to do that, but very difficult when it's just hot air that's being expended.
And also to your point as well, I think the question that you're asking is very germane going down the road 5 or 10 years as data center proliferation continues to get saturated. I mean, you're absolutely nailing it that there's a lot of lost energy within the system. And that heat, I know there's people that are exploring how to turn some turbines with that, but it hasn't quite taken commercial practicality yet.
Thanks. Well, in the interest of time, I'm cutting into lunch. I want to thank the panel for volunteering their time and their intelligence to contribute to this community, and thank you guys.